Hello, and welcome to everyone tuning in from around the world. My name is Alyssa Silverman, and I am a product marketing manager at Markforged. I will be your host for the day. I am joined by a fantastic team to walk you through the FX20 and what it can do for you. At the end of this presentation, you'll also get a behind-the-scenes look of how we brought the FX20 to life, so stay tuned. Today, you'll hear from the Director of Product Management, Tom Mascolo, who has been developing the FX20 since its inception. You will also be joined by two of our incredible application engineers, Nate Sampson and Ross Adams, who will take you through new applications that will be a great fit for the FX20, everything from the factory floor to flight. At the end, there will be time for Q&A, so please populate your questions in the Q&A box below. And with that, I would like to hand it off to Tom Mascolo to introduce you to the FX20 and the Digital Forge.
All right, thanks a lot, Alyssa, and thanks to everyone on the webinar for tuning in. Markforged is on a mission to reinvent manufacturing. And before I dive into FX20, I'm going to explain one of the reasons why, and that is the current state of the supply chain. Since the pandemic began, the supply chain, with all of its inflexibility and single point failures, has repeatedly been drawn into the spotlight. From toilet paper stockouts early on, to component shortages holding up automobile production more recently, the sensitivity of the global supply chain has become abundantly clear. Think about for a second all of the ways that you've felt the impacts of the supply chain disruption over the past 18 months. I know Markforged, here we've felt it. Have components in your product gone end of life, requiring costly redesign? Have your vendors' lead times and pricing gone through the roof as they struggle to keep up with demand? Have you lost the in-house manufacturing staff that you depend on and had trouble backfilling them? How valuable would it be for you and your business if you can mitigate even some of these challenges? Well, Markforged has a solution that we call the Digital Forge. For those that may not be familiar, the Digital Forge is our platform consisting of hardware, software, and materials that we've designed to work seamlessly together so that engineers can go from design to functional part with ease. And our platform is smart and connected, with software that enables organizations to scale and distribute their additive manufacturing operations to truly realize the vision of a digital supply chain. To replace conventionally manufactured parts, though, you need comparably functional materials. A major Markforged innovation that we've had from the beginning that's unlocked the potential for additive manufacturing is our proprietary continuous fiber reinforcement technology. Simply put, the Digital Forge creates strong parts. We've taken traditional fused filament fabrication technology, or FFF, which uses a nozzle to build up a plastic part layer by layer, and augmented it by reinforcing parts with continuous fiber, including carbon fiber. These fibers act like rebar does in concrete, adding an incredible amount of strength, stiffness, and an overall robustness to composites. So much that parts printed on Markforged printers can be made stronger than aerospace-grade aluminum with less weight. If you look at the chart to the right, that stress strain curve, you can see our continuous carbon fiber parts, which are highlighted in gray, perform against the typical engineering grade thermoplastics, which are on the bottom. So down there, we have Onyx and nylon. And even compared to 6061 T6 aluminum, which tracks along the carbon fiber curve, but the carbon fiber curve keeps going, sustaining even higher stresses. The functional performance of our technology is a major enabler. Another key enabler is the digital infrastructure on which the Digital Forge is built. Markforged leverages a cloud-first architecture, which brings major benefits to users, whether they have one printer or 100. Scaling from a single printer at a single site to dozens of printers at dozens of sites around the globe with Eiger fleet is made easy, and shared projects and role-based permissioning enables that. And our platform is enterprise ready. So with integrations for other manufacturing execution systems, enterprise resource planning systems, all of this enabling really true scale distributed production. And rooted in certified world-class security, including an ISO 27001 security accreditation, the first in additive manufacturing, meaning enterprises can embrace all the possibilities of the Digital Forge. FX20. FX20 extends the possibilities of the Digital Forge platform with capabilities and performance unlike anything we've ever built before. So why did we build FX20? We're fortunate here at Markforged to have amazing customers, many of who are on this call right now who are enthusiastic about sharing all the things they would like to see and ways they could leverage our technology. So quick shout out to every one of you who's responded to our surveys over the years. Know that myself and the rest of the product team read every single response. It's through these surveys and countless other conversations that we've had with you and other customers over these past few years that we've gotten this consistent feedback. The customers really love the strength, the accuracy, and the reliability that Markforged delivers. They just wish it were even more blank. So let me tell you about all those things that you asked for that we took to heart. You asked for bigger. The FX20 delivers, bringing the transformational benefits of the digital forge to a whole new scale. With a build volume nearly 5 times larger than the X7, you can print dramatically larger parts or a larger number of small parts unattended in a single build for medium volume to high volume production use cases. Today, we have customers breaking up large parts into smaller ones that they join together. It's very resourceful and accomplishes the goal in many ways. But this is a highly manual process, and the parts, even if reinforced, will never be as strong as the assembly is not reinforced end to end. With FX20, that entire build volume can be used to print the fiber reinforced part, eliminating this manual effort and the assembly that's required, and truly enabling the replacement of large metal parts. You asked for faster. When going as big as we have, it's almost requisite to go faster, otherwise print times get too long. With FX20, we're printing faster than we've ever printed before. Compared to the default print settings you may be familiar with on your Mark II or X7, we're going 8 times faster. And we do it while maintaining incredible part quality and accuracy that you're accustomed to from Markforged. Not an easy feat. And you asked for hotter. So for the first time ever, we're printing high temp thermoplastics, and we're reinforcing them with continuous carbon fiber. ULTEM 9085 filament has high heat resistance, chemical resistance, and flame, smoke, and toxicity compliance. These properties enable it to be used in end-use parts in industries like aerospace, defense, transportation, automotive, oil and gas, and so on. It's an incredible material on its own, but by taking this versatile material and reinforcing it with continuous carbon fiber, Markforged is unlocking more applications than ever before, enabling customers to go beyond what they're printing today to printing semi-structural parts. Lastly, smarter. No one asks specifically for smarter, but it's all the things that the smarter platform enables. The digital forge is able to leverage data from the past to predict and shape the future. Our platform benefits from flywheel effects. Our customers have over 10,000 cloud-connected printers and are frequently adding more. The more printers in the field, the more printing happens. Right now, every 10 seconds, a new part is printed on a Markforged printer. And every new print generates metadata that we use to drive insights and make the platform better, which brings improvements to the entire fleet, including your own printer. In turn, customers like the product and buy more printers, and the cycle repeats. Now, FX20 was purpose-built to fully embrace and accelerate this cycle and philosophy. Extensive system instrumentation provides rich end-to-end process visibility and performance data. Insights previously impossible to discern become clear, allowing us to push over-the-air updates that improve performance, increase reliability, and enhance the overall user experience. All right, so we've established that the FX20 is bigger, faster, hotter, and smarter. Now I'll give you a peek at some of the technical highlights that got us here. In addition to being big, it's not an exaggeration to say that the FX20 was like building a printer and an oven. The FX20 build chamber is capable of reaching up to 200 degrees Celsius, and multi-zone heating plus carefully tuned airflow patterns help it achieve high thermal uniformity across the build volume. That's really important for strong and consistent part properties. And when printing is complete, part removal is easy with a removable print sheet that's held in place during printing by our precision ground aluminum vacuum bed. Lastly, kickoff prints with ease with automated bed leveling and nozzle offset calibration, removing manual operations and inadvertent error from the equation. Now moving on to our all-new modular printhead. FX20 has not 1, not 2, but 3 nozzles, each associated with a standalone print module. 2 of these modules are for plastic, Onyx, ULTEM 9085 filament, and so on, support for ULTEM filament, etc. And 1 is for continuous fiber reinforcement. All are constructed with premium materials for maximum performance and uptime. And for all those affected by fiber nozzle drag in the past, you'll be happy to know that all of these automatically retract when not in use. Now moving up even further to the motion system. This all-new design was precision engineered for performance, from the structure to the motors to the sensors, even the file format used to control it. The result is a system that blends speed and accuracy for incredible quality parts at incredible speeds.
All right, thank you very much. And now I will hand it off to Nate Sampson, one of our application engineers, to begin walking you through our applications.
Thanks, Alyssa. How exciting is this new printer? I know everyone's dying to learn what new applications have been unlocked with the introduction of FX20. I'm sure there's some great ideas brewing in your minds already. With the introduction of FX20, we're going to be talking about applications in two main spaces: Factory of the Future, pushing the boundaries of what is possible in manufacturing, and aerospace, components in regulated industries that are now possible because of FX20. Let's first start with applications to build factories of the future. Markforged knows a thing or two about functional parts in demanding environments. We've been printing customer solutions on our composite printers for over 7 years, relieving supply chain challenges and improving efficiencies in the manufacturing floor. Killer applications like overmold, press brake tooling, lifting tools, conformal work holding, the list goes on and on. And with FX20, there's even more applications that you can achieve. FX20 is bigger, more than 4 times bigger than our industrial series printers. This means we've unlocked more of the applications you already love, like this end effector tool you see at the end of this KUKA robotic arm, but on a larger scale. Think bigger, much bigger than you have before. The bigger print bed on FX20 means single piece prints with longer continuous fiber reinforcement paths for maximum strength. Printing applications that require aluminum strength with continuous fiber from end to end is obvious with FX20. Who out there doesn't want to print bigger and faster 3D printer? Silly question, I know. FX20 delivers on both these aspects while producing strong, dimensionally accurate parts for your factory floor. This may look familiar to some of you. For some applications, our current industrial print bed size isn't big enough for single piece prints, which requires additional effort to split up the part and decide on a plan for assembly. Here's an example of a tube bending die printed on an X7 in 4 separate pieces. This job requires over 10 days of printing and assembly to have a complete functional part. FX20 can manage this large bending die in a single print at lightning speeds in just over 4 days. We all remember our first experience watching a 3D printer do its thing. It's hard to look away as you're mesmerized by this amazing new technology. FX20's incredible print speeds will be sure to draw you in like it's your first print all over again. FX20 has eliminated the need for splitting up this part in CAD, initiating 4 separate prints and assembly, while delivering the finished product in less than half the time. Now that's impressive. Some of the audience may already be familiar with ULTEM 9085 filament, while others are wondering why and when they might want to print with it. FX20 will be capable of printing both Onyx and ULTEM 9085 filament at launch. You might be interested in why you would choose one material over another. Let's cover the basics and clarify what applications ULTEM 9085 filament is great for. Higher temperature applications. I'm going to assume most of our users in the manufacturing industry don't work in nice climate-controlled environments. Hot and dirty are more common descriptors of the average manufacturing facility. ULTEM 9085 filament is a strong material that maintains its strength through a higher temperature range, making it a great fit for applications in paint curing booths, parts washers, and autoclaves where higher temperatures are encountered. ULTEM 9085 filament has excellent chemical resistivity. FX20 creates the opportunity for applications that are exposed to ammonia, various acids, hydrogen peroxide, and tar, to name a few. It's also great in high voltage applications where its dielectric strength comes into play. Customers are printing bus bars on our Metal X system out of pure copper filament that can be protected by conformal ULTEM 9085 prints. This material uniquely provides strength at high temperatures where insulative properties are required. Markforged is clearly reinventing manufacturing with FX20. It's obvious the factory of the future revolves around FX20. I'm going to hand it off to my fellow application engineer, Ross Adams, to walk you through applications in the aerospace industry.
Awesome. Thank you, Nate. Exciting stuff with the factory of the future. This is definitely a trend that we're seeing. And with the FX20, we're definitely expanding the scope of applications that we can place into your factory with 3D printing. We're going to be shifting focus now and focusing a little bit more on the aerospace vertical. My background is in aerospace tool design, and I really feel like aerospace is going to be the largest industry that will have an impact with 3D printing. And I truly feel that Markforged is going to capture that largest market share. So let me tell you why. When we think about aerospace, 3D printing is really in its DNA because of a few core elements. The first thing is the volumes that aerospace works with. Unlike automotive or iPhones or footwear, where they're making millions of parts per year, aerospace is a lower to medium volume, talking about like hundreds to thousands of aircrafts per year. And additive manufacturing scales very nicely to those types of volumes. Whereas when we start talking about millions, there's a lot more investment that you need to bring the technology in-house versus a lot of low-hanging fruit applications that you can attack when they meet these types of volumes, because 3D printing is going to be slower than some other methods. So you need to find the right sweet spot for applications that you can pursue with it. The second core element is the complexity of their manufacturing processes. So in aerospace, we're trying to optimize for aerodynamic efficiency. So parts are often having smooth contours, and the trade-off there is that the manufacturing processes get more expensive and time-consuming to achieve those contoured components. With additive manufacturing, though, we have the ability to have complexity at a much discounted cost, because as we're adding material, we're not removing it for those smooth contours that might require like 5-axis CNC machining or autoclave molds. Then the third key element is the impact of weight reduction. In aerospace, this is very high because the lighter weight parts that you put in the aircraft, the heavier of payload it can carry, the faster it can fly, and the longer durations it can go. Additive manufacturing inherently is great at lightweighting because we have the ability to add material just where we need it, utilizing honeycomb infills and high performance materials. So these three elements combined together dictate the sweet spot for additive manufacturing. And with the introduction of the FX20, we're really expanding the application scope and giving you the tools you need to apply the technology in end-use aerospace applications. So in order to know where we're heading, it helps to know where we came from. And I want to share a story today about the history of the helicopter. So Igor Sikorsky had the vision for the helicopter and brought it to America to make it a reality. When he started building these prototypes, he had a realization that the technologies used to build engines resulted in engines that were too heavy to overcome the laws of physics and create enough lift to allow the helicopter to go into flight. What he was forced to do was actually build fixed-wing aircrafts for over 20 years, keeping a very close eye on the engine technologies. And the second that those technologies caught up and allowed engines to be lightweight and afford the flight of a helicopter, he made this a reality and really changed the course of mankind forever. Sikorsky estimates that over 2 million lives have been saved with the invention of vertical takeoff. And I share this story not because I think that we're going to be 3D printing engines in the future, although we do make metal printers, so I wouldn't discount that. But I share this story because the understanding of where we might be at today with technology and how the limitations of the technologies that we're using today are restricting innovation. As we introduce new technologies, where might we be heading in the future with lightweight designs and the future innovation within the aerospace industry? Let's dig into that. Now I'm going to be levering to one of Markforged customers, SRC. They are become an early adopter for the FX20, but have also been utilizing our industrial series X7 printers for well over a year now for end-use flight-ready parts. They specialize in research and development for radars and electronic warfare systems. They have a very strong reputation in this market. They've been a 3-time winner of the U.S. Army's top 10 inventions since 2004. And their customers include branches of the DoD like the Army, the Air Force, Marines, Navy, Homeland Security, many more. But the common thread here is that these types of branches are always facing new types of challenges and threats within the field. and they come to companies like SRC to invent new solutions to counter those threats and give them enhanced security when they're in combat. Oftentimes when these issues are discovered, they come in the form of a quick reaction program. So there's going to be multiple companies bid in to develop their solutions, and whoever has the best design is going to be awarded the contract. As these companies are bid in, there's three main criteria that they are being evaluated on for who has the best design. First being time to market. So because these threats exist today and a solution was needed yesterday, whoever can develop a solution the fastest has a superior advantage because they can start protecting lives starting now. The second core element is design optimization. And this is kind of a trickier one to put your finger on because there's a lot of different elements that go into optimizing designs. But whoever can create the best solution that does what it needs to do and then has the secondary benefits of being light and reduced form factor have an elevated advantage within this evaluation. Then the third key aspect is cost effectiveness, probably lesser important than 1 and 2, but always important whenever you're designing anything that if you want your solution to scale, it needs to be cost effective enough that companies can adopt it. Now, I'm going to be spending some time and focus on design optimization because unlike time to market and cost effectiveness, where we know we're just trying to reduce it, optimizing designs often comes with trade-offs. So you prioritize one advantage and deprioritize a benefit that maybe you can't discover because we need to optimize the design and make it a reality. So what does design optimization look like? SRC's customers use the acronym SWAP compliant. SWAP stands for space, weight, and power. And the goal here is to minimize the amount of space that the part takes up and using design principles and lightweight, high performance materials to make the part as lightweight as possible. If we reduce the weight and reduce the space, we can maximize the power output coming from the system. And a 3D printer is really a tool to achieve SWAP compliant designs. Inherently, you can take an assembly that used to be 10 components and make that into a single unified body and reduce the form factor, but also with design principles. So traditionally, you might drill some holes in aluminum to make these lightning holes and make the part less heavy and reduce the stress concentrators in areas that you don't need material. Or also you use high performance materials. And high performance materials, when you look at aircrafts, there's very little plastic goes into them, even less steel. It's mainly composed of aluminum, titanium, and composites. As time has gone on, we've seen an increase in the utilization of composites on structural components. And this is really afforded with the technologies that we have been able to scale out in the world. Right now, we're looking at almost 50% of airframes are made out of composite materials. I think that trend is going to keep going up. But right now, they're limited because composite traditionally are very labor intensive and have a lot of tools that go into that process. You need the molds, you need the clamps, you need an autoclave, you need to do the curing, and then you need secondary tools to do your drilling and your trimming templates around the final part. And for that reason, it's not always cost effective. It doesn't always make sense, and it's going to delay your time to market if you're trying to utilize the lightweight and benefits, but also balance that with bringing a product to market as soon as possible. And this is where we're changing the game, because now we are taking the benefits of these super materials that are true composites and we're 3D printing them. So this is a toolless process with minimum supervision. We can take a continuous spool of continuous fiber, route that into a precision nozzle, additively manufacture parts, but embedding those fibers continuously into the geometry. And the result is strong and complex parts that come right off the print bed and ready to use inside your aircraft. So we're taking all the tools out of the equation, we're minimizing the supervision and enabling you to utilize these materials and not be prohibited with the traditional methods that block you from using these materials and substitute them instead for like aluminum or titanium. And we have a wide array of fiber materials. We really understand that engineers, always are going to be facing different types of challenges, and you need to tailor the materials you're using to the specific application. So look at these materials, we have stiffness, we have compression, or we have impact resistance. But the fibers are never alone in the material itself. A composite is the combination of two materials working together to achieve a high performance material. And for the first time ever, we are offering ULTEM 9085 filament. And this is going to be a game changer because temperature is one of those elements that comes down to the chemistry of the material. Either it can meet the temperatures or it cannot. It's not like strength where you can just make your features thicker to achieve higher strength. So being able to use these continuous fibers with these order of magnitudes increase in strengths, but combining that with a high temperature resistant material that can withstand temperatures in these extreme environments, you have the confidence as an engineer to send these parts into production and then start having them fly and exploit the benefits that you get from lightweighting and reducing space. So now let's circle back to SRC. And I'm going to be talking about a specific program that they utilize the FX20 for and realize some advantages of this manufacturing process. And overall, that gives them a competitive advantage in their market by achieving higher performance solutions. First up is time to market. So by taking 3D printing and bringing that in-house, they're able to reduce their lead times from months all the way down to days. Not only does that reduce the amount of throughput that you can utilize on a part-to-part basis, but in the design cycle, they can now go through a series of prototypes within the single amount of time that used to take them just to get one part. And how do you optimize your designs? Well, you design them, you manufacture them, you test them, and then you iterate, and you iterate, and you iterate, and you improve. And that's how you arrive at optimized designs. You never really know when it's optimized because at some point you need to put the halt on and start going in production. So the more iterations you can get through, the more confidence you have that you achieved your optimized design. So with the iterations that they went through, they were able to achieve a 15% weight reduction without making any sacrifices to strength. They did this compared to a machined magnesium design that had all these lightning pockets and stuff like that, but instead utilized ULTEMTM 9085 filament reinforced with continuous carbon fiber, and they're able to exploit the true composite materials, which would have taken them months to get if they pursued it traditionally. 15% is big. It means that the aircrafts have higher uptime, spend less time coming back down onto ground and refueling, and then going back up to have their surveillance and protection. So this is a massive improvement and gives them the competitive advantage against their competitors. And then lastly, cost effectiveness. Again, lesser important than 1 and 2, but still something that is evaluated and something that you're trying to optimize for. By bringing the process in-house and utilizing 3D printing, which has very reduced amount of tools involved in the manufacturing, they're able to realize a 25% cost savings by eliminating the tools and eliminating the outsourced vendors that they used to leverage to make these types of components. These three elements together are afforded because of the FX20, because they have the materials that are strong enough to go into flight, because the materials have temperature resistance to withstand in these extreme environments. You empower your engineers to give them the tools they need to achieve optimized results. And this is what's really exciting about the FX20 and why I'm very optimistic that the future is very bright for a continuous improvement of the amount of composites that go into end-use aircraft components. So I'll be passing it back off to Alyssa and looking forward to seeing the questions that everyone asks.
Thanks, Ross. So this is what happens when we bring a bigger, faster, hotter, smarter printer to the Markforged lineup. We're very excited to see what our customers do. And with that, I'd actually like to share with you a behind the scenes look in the making of FX20.
So we're about to go look at something that no one outside of Markforged has ever seen before. This is top secret.
FX20 is the most ambitious product Markforged has ever taken on. Bigger, faster, hotter, smarter.
We really set out to build the best printer ever for engineers by engineers.
The number one request from our customers has been they want to print larger parts. Going bigger is really hard. When you expand things in X, Y, and Z, you encounter all new challenges. By going faster, you need stronger motors. When you have stronger motors, you need a stiffer motion system. It makes the technical challenge exponentially harder.
The mass goes up, which means controlling the thing becomes more difficult. The FX20 is massive. We made this thing several times larger and that problem got way more difficult. This is what the printer looks like on the inside. This is an enormous mass that has to move up and down. It needs to be in the exact right place so your part comes out the way that you want it to.
In addition to just going bigger, you really need to go faster, otherwise you'll be waiting a long time for your parts.
FX20 will allow you to do everything you're used to, but you're going to be able to do so faster, much faster.
With FX20, we're able to go multiples faster without reducing surface quality or finish or accuracy of our parts. And when it comes to hotter, we're enabling FX20 to print Onyx, Onyx FR, Onyx ESD, nylon white, all of our continuous fiber reinforcement materials, carbon fiber, Kevlar, fiberglass, high strength, high temperature fiberglass. Plus it'll print
ULTEM 9085 filament.
which is our first high temperature thermoplastic that allow our customers to address an even wider range of applications that they've never been able to address before.
This is going to allow people who are currently 3D printing parts and putting them into airplanes and really bring those up to the next level.
High temperature thermoplastics like
ULTEM filament.
are really the top of the polymer pyramid.
We're not the first to print ULTEM filament.
We're adding continuous fiber reinforcement to it to give it the strength of metal. Totally changes the game. Lastly, Smarter. Our platform, the Digital Forge, continuously gathers data, and we've developed FX20 to capture orders of magnitude more data. Once you have that data, you can use it to control the printer and create ever better parts.
There's optical sensors in there, and based on that, we set the speed of the extruder.
Yeah, buddy. Love it. This printer has more sensors on the print head than all of the sensors on our previous printer combined, capturing all the data that that machine needs to learn, get better, and deliver the perfect part.
This is a printer that's going to continue to get better over time. The day you buy the FX20 is going to be the worst day it ever performs. And it performs really well from day one. So we have a motto here, which is that the part is the product. And that's been central to the development of FX20, from the size of the parts, the speed with which you can print them, the materials that you can print, and ultimately the quality of those parts.
Markforged is known for making real parts, and that's our key differentiator. We bring the function, and form, fit, function, those are like the core things in engineering, and the FX20 is going to take that to the next level.
The surface finish on our parts is better than anyone else's, and there's this tight association between what does the part look like and how high quality of a part it is.
One of the challenges to achieving a really good surface finish is differences in the bed position of the thickness of my hair will show up in the part quality. And we've been through 4 different iterations of this print bed, chasing down that thickness of a hair, and we actually had to reinvent the entire print bed in order to accomplish that. So we redesigned it from the ground up, and we have a much better product now. We're making this bigger, faster, and hotter. We are not making it any less accurate.
One of the defects that we see that are problematic is Z-banding. This is when your system is not mature enough to be able to move the bed at a consistent layer height. It got better. This right part here is the current printer. After we've implemented a lot of hardware and software improvements, and this is the kind of surface quality that we expect to ship with this printer.
The FX20 engineering team is just a dream team of cross-functional engineers that are top of their class in every discipline. So we solve things in a very systems engineering way.
So every time you look at a Markforged part and it looks beautiful, that didn't come for free. That's literally thousands of hours of engineers staring at these parts under a microscope, fine-tuning every detail of the system in order to achieve that piece of quality. And this is the same approach Markforged takes on every printer and every product.
The products we're designing are for people like us. Customers that wanted to rapidly iterate functional prototypes, that want to manufacture products. And what we're doing with FX20 is really taking it to a whole new level. Super excited to see FX20
Start shipping to our customers in 2022 so they can build with it.
and start creating value for them and their customers.
Hope you enjoyed that. It was great to get a look behind the scenes. Really great to work with our engineering team building this. So thank you all for joining us today to learn more about FX20 and an ULTEM 9085. The FX20 and ULTEM 9085 filament are expected to ship worldwide in the first half of 2022. We are now accepting pre-orders, so if you'd like to learn more, please visit our website, markforged.com, or contact us at sales@markforged.com. Also, please look out for an email coming to you later this week with the recording of this presentation. And with that, we'll move on to our Q&A section. So again, if you have questions, please feel free to type them into the Q&A box at the bottom of your screen, and the panel will begin to answer them. Okay, we're going to start with our first question, and this one is for Tom. What is the size of the build chamber?
All right, this is an easy one. So the build chamber set, the buildable area is 525 millimeter by 400 millimeter by 400 millimeter. And that's when printing with a single nozzle. So that would be if you want to print, just an Onyx part as you do today. If you want to utilize all 3 nozzles, so say for example you're printing ULTEM 9085 filament with support for ULTEM filament material and carbon fiber for ULTEM. If you want to utilize all 3 of those nozzles, the build volume size is 500 millimeter by 400 millimeter by 400 millimeter. So you lose 25 millimeter in width.
Great. Let's continue on that size path for a second and answer how large are the spools of material?
All right. FX20 will print, all of our current 800cc spools, but we're also releasing an XL spool, which has 3,200 cc's of material on it. And that will be for ULTEM 985 filament, for support for ULTEM filament, and for Onyx.
Next question. What makes FX20 faster than the X7 turbo print?
Yeah, so a number of engineering innovations went into making FX20 faster than turbo print is on the X7. It comes down to how quickly can material be deposited. And on FX20, we've been able to move the print head faster. We've been able to extrude the material faster. All of those things requiring more heat in the print head, stronger motors, better motion control. And as I mentioned before, we've always had our proprietary print file format, which we've used to better control our printing parameters. And we've really evolved that format to have an even higher level of precision and control in our printing process. So it's really is the culmination of hardware, software, materials innovations that are allowing us to go faster while still maintaining that great Markforged quality.
Great, thanks, Tom. Definitely see a couple questions here about if the FX20 prints metal.
So we do not have any current plans for FX20 to print metal. Good question, though.
Okay, definitely a couple questions about ULTEM filament supports. Are they removable by hand like Onyx?
Yes, so our standard support for ULTEM filament material was developed to work specifically well with ULTEM 985 filament, and it is a breakaway support material. Some of those parts just easily break away by hand. Others do require some tools depending on the complexity of the shape, not too dissimilar from if you're printing with Onyx today. What led us to this support material for ULTEM is the fact that it is much easier to remove than other support materials that are on the market for ULTEM 985. And so there's elevated temperatures and gloves are not something that's necessarily required to remove the support material from ULTEM filament.
Great, thanks, Tom. All right, there's a lot of questions about cost. How much does the FX20 cost?
All right, very glad there's a lot of interest in FX20. To get cost information, please reach out to your local partner or reseller or sales contact at Markforged. Or if you're not sure who that is, you can log on to our website and click this request a quote button and we'll be in touch.
All right, next question. Is the FX20 office ready? So I think talking a little bit about facility requirements.
Yes, we absolutely designed FX20 to be office ready. A couple of things there. So we designed it so that it can actually roll through a standard 36-inch wide doorway, which you see is very common in office facilities here in the United States and over in Europe as well. It does require a dedicated 3-phase power drop. So this one won't just plug into your 110, 120 volt outlet in the wall. It does require a dedicated power drop because of all the power it consumes to get up to 200 degrees Celsius. And connects to the digital forge, to the internet through an Ethernet, RJ45 connection, typical Ethernet cable.
So there's definitely a couple questions around having laser scanning capabilities or Blacksmith enablement. Can you talk to that?
Sure. So, Blacksmith is this big overarching, technology that we have here. It's really about autopilot for manufacturing. The first instantiation that we have for Blacksmith has been on the X7 utilizing the laser. We definitely have plans to do Blacksmith on FX20, although using a different sensor package. So FX20 does not have a laser, but it does, as I mentioned before, have extensive telemetry and extensive sensors all over it. And so leveraging that data to fulfill this autopilot for manufacturing concept is in the plans. Great.
There's a question here about having any sort of demo So I do want to let you know that very soon we will be releasing a virtual tour. You saw some snippets of that in Tom's presentation today, where you can basically walk through the printer. So that will be the easiest way to see what's going on inside the printer to start. And then moving forward after that, of course, we will be having demo units at our partners as well as on site. We will be showcasing FX20 at Formnext printing for the first time next week. So if anyone is coming to Formnext, please visit our booth and you can actually see the FX20 live. And you can actually see parts as well. We're very excited to showcase it there.
All right, I see a couple more detailed technical questions in the Q&A, so I'll start going through these. One question is it still a Bowden tube style feed for the printhead, or does it have a direct drive built into the hot end? And the answer is it's a direct drive system. So the extruder is built into that printhead module. Another question in here, can we use standard infill with ULTEM parts, triangular, hexagonal, etc.? Early on, we're sticking with triangular infill on ULTEM material, and over time we'll expand to other infills. But yes, we have the standard infills for ULTEM parts. Question here about, does FX20 print continuously in the Z-axis? That is, the holy grail of fiber printing. And no, it's 2.5 dimensions basically. So we all of the continuous fiber reinforcement that you're familiar with on your Mark II or on your X7 today, similar reinforcement strategies will be enabled on FX20.
I've seen some questions come in about like training and educating your engineers on this new process. So Markforged, we have a virtual training curriculum called Markforged University. And this is really how you equip your engineers to design for the process, just like you would do with sheet metal or injection mold, and additive has its own element. And this is a great way that kind of helps you streamline your process, so you don't have to go through 6 months of failing and learning and just, get to the adoption curve much quicker. So Markforged University will bridge that gap.
All right, some detailed questions here about fiber reinforcement. So question is it possible to change fiber ratios of parts to achieve specific tensile strengths? And another question about the fiber volume fraction content. With our Eiger tool, there's a lot of flexibility that users have to reinforce fiber, select which layers they want to reinforce with fiber, where they want to reinforce fiber, which strategies they want to use. So we have what's called an isotropic fiber fill, where we basically print an entire panel of fiber. And then we also have concentric, which will trace fiber around the perimeter of the part and any internal holes. So a bit more of an efficient placement of the fiber there. And in our Eiger tool, you can see how much fiber is in the part versus how much plastic is in the part and the overall volume of the part. And based on that, determine, based on the strategy you've employed, what is the actual volume fraction of fiber. There was another question I saw about when users will be able to log into Eiger and start slicing parts in FX20. And our goal is to have that capability opened up early in 2022. We want to make sure all the data that you're getting out of that will be accurate. Question here about, will you release ULTEM or a version of it to printers other than FX20? FX20 was built with a heated build chamber, a print head with capabilities to print, to melt and melt process ULTEM filament. The other printers in Markforged lineup don't have that capability. So we have no plans as of now to offer ULTEM or a version of it on our other printers.
Seen a few questions come in about like applications within your factory. A great way to help you discover what the best applications are is to get in touch with your local sales contact, and we can talk more about your current state manufacturing operations, and we'll be able to kind of tailor some of the applications that we see in other companies to help you discover where the low-hanging fruit are and where you can be heading with the technology in the future.
One question about the maximum temperature inside of the build chamber. So this build chamber has been engineered to reach up to 200 degrees Celsius and maintain that with high thermal uniformity. In order to print ULTEM 9085 filament, we don't need to go that high, but we've built the platform with the performance headroom to offer additional high temperature thermoplastics in the future.
Tom, there's an interesting one here. Will there be dry boxes for the large spools?
Yeah, so this is if this is a question about dry boxes for the desktop and industrial. The answer is we have no plans right now, but are considering having a retrofit dry box kit so that users who do eat through quite a bit of Onyx can buy and use that 3200cc XL spool. So under consideration.
Do you want to talk about the advanced material cabinet?
Sure. So FX20 below the build chamber has an advanced material cabinet, like Alyssa mentioned, capable of storing 4 XL spools, 3200cc spools of filament. It also has a very sensitive moisture sensor to monitor the moisture level inside of that build chamber and infer moisture content of the filament itself. All of that to ensure the properties of the part, the properties of the filament going into the process, and therefore the part itself are of quality that's satisfactory.
Okay, some questions around other high temp polymers. Will things like PEEK and PEC be available on the FX20?
We have nothing publicly to say about other materials that are in development, but we have built FX20 with that capability and with that headroom to print other high temperature thermoplastics. So if you have specific applications in mind, we'd absolutely love to hear from you. So please reach out to us through your sales contact or applications engineer if you have a contact.
Looks like we only have about a minute left. So I think we're gonna wrap up. Want to really thank everyone so much for your time today. This has been a really great hour. And we're excited to talk to you and see what's going on next. So again, if you're at going to Formnext next week, please come stop by the booth. We'd love to show you FX20 in person. And if not, we'll be in touch. Thanks so much.
Thank you, everyone.